Hi, so today I'm going to do an example of an A-level static electricity problem. So this is a Coulomb's law problem in 2 dimensions. So we have to deal with both the horizontal and the vertical components. So this is an A-level and it's one of the ones that a lot of people have to do multiple times. So be patient on this one, be careful, and once you get the idea, you'll probably be able to do pretty well on that one. So we'll have 3 charges in a triangle usually, and this is a plus 10 nanocoulomb charge. This is a plus 8 nanocoulomb, and this is a minus 10 nanocoulomb charge. We've got 1 centimeter separation here, and we've got 3 centimeter separation here. The question that we are asked is, what is the net force on the left-hand charge? So what is the total force that this positive 10 nanocoulomb charge feels due to the other 2? So basic Coulomb's law, we're going to have a force of the negative 10 acting on the positive 10. We're also going to have a force of the positive 8 acting on the positive 10. And we'll have to add those as vectors. So to start with, what I really recommend you do first thing is draw the 2 force vectors for what's happening between the charges. So you are the 10. What do you feel? You are this positive 10. What do you feel from the other charges? Well, I'm a positive 10. There's a negative 10. We're attracted to each other. And so I'm going to have the force from the other 10 is going to be pulling me that way. The force from the 8 is going to be, let's see, we're positive and positive. So we're repelled from each other. And now, all right, is this going to be stronger or weaker? Well, the size of this charge is a little bit smaller. So this is a 10, this is an 8, so that means I'm going to have a little bit less of a force. And the distance, well, this has to be a bigger distance than this as well. So that also means a smaller force. So I'm going to guess we're going to have a smaller force due to the 8, and it's going to be repelling me down in that direction. So what do? I got to figure out how big those forces are, and then I'm going to add them up as vectors. Okay, so force of the 10 on the other 10. K, 9 times 10 to the 9, that's constant, times charge 1, okay, that one's easy. Nanocoulomb is 10 to the minus 9. On charge 2, 10 to the minus 9 again, over the distance between them. Well, the distance between there is 3 centimeters, but it's not 3. We need to have it in meters, so 0.03 meters squared. Don't forget that squared. So that's the value of the force of the negative 10 on the positive 10. And if we do that math, it should come out with 0.001 newtons, pretty small. The direction of that thing, straight to the right. That's the easy one. That's the easy one. Now we go to the harder one. So what is the force of the plus 8 on the plus 10? So we've got the 8 acting on the 10. Well, it's going to be K, constant, 9 times 10 to the 9, times charge 1, 8 nanocoulombs, times charge 2, 10 nanocoulombs, over the distance between them, which is what? What is the distance between the 8 and the 10? We don't know it to start with. We're going to have to figure it out. But I know the 2 sides of the triangle, so the distance that I'm looking for is this distance right here. That's a 3, that's a 1. I can figure out the 3rd side of the triangle. So if I have it's going to be the square root of 3 squared plus 1 squared, which is the square root of 10. Ugh. 3.16? Okay, yeah, 3.16 centimeters. All right, so I have to figure out what that distance is between those 2 charges since I wasn't given it in the problem. And now that goes down here. The distance between them is centimeters converted to meters, so that's in meters now. And then don't forget to square it. Here, I'm going to guess it's a 72 times something. Yep. So this is 0.00072 newtons. And it's at some angle downward. Okay, so now we know the sizes of both of those forces. We know how big the 10 is pulling, and we know how big the 8 is pushing with. I want to know the total force. How do these 2 add together? So to get that, what I recommend you do is figure out all the horizontal components of the forces, all the vertical components, and then add them together to get the total horizontal, total vertical. So my first one is the easy one. There's always going to be an easy one. So the force of the 10 on the 10, well, okay, that's going straight to the right. There is no up-down component at all. There's no vertical point of this vector. So nothing up, down. It's all entirely to the right, so it's all there and right, positive. Don't forget the signs. That's one of the biggest mistakes, is getting the signs wrong, which is another reason I recommend you do this, draw these arrows first, because those arrows are going to help you figure out the signs in this chart. So now we've got the force of the 8. Okay, so the force of the 8, well, all right, that's in both the x and the y directions. So how can I figure out those components? Yuck. All right, so let's see. I need to know the horizontal component, and I need to know the vertical component. I know the hypotenuse is the whole thing, 0,0072. In order to figure out these two sides of the triangle, I need to know what that angle is. So what is this angle? Well, how can I figure that out? I do know that that is the same angle as this right here, which is the same angle as this one. Right? Nope, it's the same angle as this one. This one. There's my theta. So I better erase that. These things don't erase when they're wet. All right, so angle from the horizontal, angle from the horizontal. Well, that's going to be the same as this angle from the horizontal. Okay, so if I draw a little triangle here, and this is my angle. I know this is 3.16, this is 3, and this is 1. If I want to know what that angle is, I can do inverse tangent, inverse sine, inverse cosine, whichever one. I like 1 and 3, they're simple. So I'm going to do the tangent, opposite, and adjacent. So the tangent of the angle is 1 over 3, which means my angle is the inverse tangent of opposite over adjacent. And if I do that math, I get 18.4 degrees. Okay, so I know my angle. Woo! So this angle is the same as this angle, which is the same as that angle. So now I know that this angle here is 18.4 degrees. All right, so that was all in preparation to do this step. So now I'm going all the way back to figure out this step. Here's my x component, and here's my y component. The horizontal component, this piece right here, the x component, is going to be the cosine component, because the cosine component is the adjacent component. So this is going to be my force times the cosine of the angle. And now I'm noting this is going to the left and down, negative. It's going to the left, so it's a negative x component, negative horizontal. And y is also negative, f, and this is the opposite of the angle, f sine theta. So I'm going to have negative f, which is 0.00072, times the cosine of my angle, 18.4. And if I do that, I should get negative 0.000683. And something really small, negative 0.000227. Okay, so now I know the horizontal and vertical components for this force, and I know the horizontal and vertical components for this force. I want to add up all the horizontals, add up all the verticals to get my final triangle. So when I do this, well, okay, this one I can add up easily. 0 plus that is just that. 7. This one, oh, that isn't, oh no, it's subtracting. So plus 0.001 minus that. I'm going to cheat and look at my notes then. That'll give me a plus 0.000317. Okay, now we're not done yet. This isn't the net force yet. This is just the horizontal part of it and the vertical part of it. To finish it off, I actually have to find the true vector associated with these components. So I'm going to go to the right with 0.000317, and then I'm going down with 0.00227, And the actual final answer that I want, the F net, squeak, is this thing right here. Now, does it make sense that this is going to the right and down? Down and to the right. Huh. Well, okay, up, down I'll give you, because this doesn't do up or down, and this one goes down, so definitely down. This must have been way stronger than this one, because we not only balanced out that right hand, but we got a lot more going that way. So, yeah, it makes sense. And again, this is one of the things you can do to check that your answer makes sense. Does this make sense adding these two vectors together? Big one to the right, littler one, smaller one, down to the left. How do we get F net? So what do we do to get F net? Well, we're going to do the Pythagorean theorem. So it's going to be 0,00317 squared plus 0,00227 squared. Square root that. And so the final size of the force, 390. So the size of the force that this positive charge feels from this one and this one is 3.9 times 10 to the minus 4 newtons. Tiny little force. But forces are vectors. And that means we have to have a size and a direction. We need to know what direction this is going besides down and to the right. So I want to find out what that angle is. And I'm going to do exactly the same thing I did here. I'm just going to use the inverse tangent. So my angle, this is getting low, is the inverse tangent of, opposite over adjacent, 227 over 317. Wow. And if I do that, I get 36 degrees. Now, 36 degrees alone doesn't tell me what direction it is. So just saying it's at 36 degrees, not helpful. It could be 36 this way, 36 this way, 36 this way. I need to know more than that. So the proper answers for this one, there's a bunch of different formats it can take. So I'll give you an example for different ones. So it's 36 degrees below the positive x-axis. That would be one way, because with positive x-axis, 36 degrees down. Okay? A negative 36 degrees would also work. If you give me a positive or a negative, I know we're going based on the whole 0 to 360 circle. You could say positive, what would that, 324? Positive 324 degrees. So then I'd start with 0 and I'd go all the way down to get to there. 36 degrees south of east, that would be another way to do it. Those would all be perfectly legitimate answers. You could also give me this angle. If you did the down and then over, so if you went like that and then that, and figured out this triangle, well, you still get F net's the same. Your answer for F net is going to be the same, which, well, it better be at least. But then you would probably determine this angle, and you could, well, I mean, that would still be plus 324 or negative 36. But if you did that, it would be, what, 54 degrees east of south? That would also work. So that would be another answer. So the final answer is the size of the force and the direction in one of these ways. I don't care which one, which format you use. Give me something that tells me exactly where it's pointing. So this is an A-level question. So this is the A-level for static electricity. A lot of vectors, you know, a lot of forces as vectors, and a lot of trig. But once you get the process down, I think so long as you're careful with your signs, you should be okay. That is the biggest mistake people make with this one, is getting a mistake typically here with the signs. So watch that. Make sure your final answer makes sense with the answer you've got up here, and you should do pretty well. All right.